that we are going to discuss about the molecular mass. We'll continue discussion. We have found that all colligative property methods can be used for determination of molecular masses. Of course, there are some problem in determination of correct molecular mass by some of the experiments, but if you can take care of all this your fault, then you will get correct molecular mass. But out of that, we found in our ordinary laboratory condition, we have found that osmotic blood pressure method is the best one. But in case of a sophisticated laboratory, you can adopt any one method for determination of molecular mass. But it is strange, we found that some of the compounds, even after following the correct procedure, most sophisticated method could not give us the right molecular mass. Okay. So initially we thought that maybe there are some problem with our theory, but when we checked it, we found the problem is not with the theory, the problem is with the compound. Okay. So this type of incorrect molecular mass that you get it by corrigative property method is called abnormal molar mass. Right down.
Done, sir.
Okay. Now, why it is like this? Such abnormal molar masses can occur due to association due to either association or dissociation of some solute Okay. So let us try to understand that what is association of solid molecule. You will not write. Association of solid molecules. Okay. So remember your school days. Now you are not going to school almost a year, I think. See, when you go from home, you go individual. Your parents or either you go and drop by the side of the school. Then after that you go. All of you go to the classroom individually. You sit also in your respective places. But moment there is a break, suppose in your classroom, you have 50 boys and girls. Oh, I will make it not 50. Okay, say it is 40. And there 20 boys are there and 20 girls are there. In your tiffin time, what happens? You'll find you come out of the class and sit in groups. Maybe a group of 4 or 5 like that. So, in that case, when you are in group, you behave similarly. Suppose someone has to inform some important thing to you, then he need not go and meet all the 40 students. He will go and tell one member of the each group. Immediately the thing spreads. So there are some molecules also when you make a solution, they come together and form a group. When they form a group, they are inseparable. By that way, what happens? 40 molecules are there in the solution. Maybe that two of them has made a group and they are inseparable. Now in the solution, you do not have 40 molecules free. You have 20 groups. So what has happened? We know in colligative property, the colligative property depends upon the number of particles present. Theory does not mention about the molecules, particles. So 40 molecules, two of them has linked with each other. Immediately now they exist in the form of 20 groups and they're inseparable in the solution. So the number of particles, free particles in the solution has decreased from 40 to 20. And I have told you that colligative property is directly proportional to the number of particles present. Now you have added 40, it has become 20. So it has become half. The colligative property also will be half. All right. Now, again we know that the colligative property is inversely proportional to the molecular mass. If it is inversely proportional, then the property has become half, molecular mass will be double. Okay. So because of that, we find that we could not get the correct molecular mass of the compound. That molecular mass has become double, triple, 4 times, depends upon how many molecules are associated with it. So it is not the fault of the theory. It is fault of the molecules that you have released them in the solution. So this is called association of solute molecules. All right. So you'll find, see, I have written down detail. I have written down. Okay. So before that, I want to show you a molecule. Say you have added here carboxylic acid. See here, very interesting. It is found when if you release two carboxylic acid molecule in the solution, this molecule in the solution does not exist as individual molecules. It exists in this form. See here, it is being held by hydrogen bonding. So two particles in the solution is behave like a one particle. So this is the individual molecule. Individual molecule. And this is the associated molecule. See here. Here you have two particles. Here you have one particle. All right. So in a solution, if you have added n number of carboxylic acid, so what is going to happen? Is going to give you n by 2. See here. This become n by 2. So what will happen now? The value of colligative properties will be reduced to half of the original value as molecular mass of solute is inversely proportional to the colligative properties. So, molecular masses determined will be double of the original. This is for carboxylic acid. Okay. If you have taken some other molecule where three of them form a group, then the colligative property will be 1/3 and the molecular mass will be 3 times of the original one. Write it. All the written part is there in the note. From there you can read. You have to understand. Proof. It has been experimentally found that acetic acid, what is the formula of acetic acid? Okay, I'll write down this. Exists as dimer in both non-polar solvents. Example, benzene. As well as in vapor state. Okay. So it is a dimer in non-polar solvents or vapor state. Why I am saying vapor state? Because I can find out molecular mass by lowering in vapor pressure. Okay, relative lowering in vapor pressure, then it will go to the vapor state. Otherwise, it will exist in solution. Okay. So the molecular mass of acetic acid determined by colligative property methods is found to be 120 gram mole inverse, which is double of the original molar mass, 60 gram mole inverse. Now we'll go for dissociation. See, I can give you an example where 3 molecules were also associated. Okay, I'll not give. Okay. Now, second one is dissociation of solute. So this happens with salt. Molecules of certain substances like acids, bases, and salts that we know they undergo this. Dissociate or ionize. In a solvent to give 2 or more particles. Okay, example, say I have taken here sodium chloride, I put it in water, what will happen? It will give you Na plus. Okay, I'll write here aqueous Cl minus plus. Okay, I have taken here barium chloride, aqueous Ba2 plus aqueous 2Cl minus aqueous. Suppose I have taken here ferric chloride, aqueous, it will give you Fe3 plus aqueous 3Cl minus aqueous. See here, I have added 1 mole, means Avogadro's number of particles. It broke down to give you 1 mole of sodium ion, 1 mole of chloride ion. The number of particles has become double. In this case, I have taken 1 molecule, it has given us 3 particles. I have taken 1 molecule, it has given us 4 particles. So this type of thing happens. So what is going to happen? In this case, the number of the particles has greatly increased. All right. Consequently, the total number of particles in the solution is greatly increased. So the value of colligative properties will be large. Okay? Since colligative properties are inversely proportional proportional. Therefore, the observed molecular masses will be less than their actual values. So in this case, the molecular mass of sodium chloride is 58.5, but it will be half of the 58.5. This will be 1/3 of the actual molecular mass. This will be 1/4 of the actual molecular mass. How to overcome this problem? How to rectify our theory now? Okay. So this is being done by a person called Fontov. So now we'll introduce, Fontov is introduce a factor called Fontov factor. Okay. BAN. Sorry, little mistake I have done. V is small. Spanish names are like Fontov. See, here this pronunciation is not want. Pronunciation is font. Like you know, there is a very famous car company is there. Their cars are very costly and very good. We call it Volkswagen, but actually it's not Volkswagen, it's Volkswagen. It's called Fontov. Okay. So now we write Fontov introduce a factor called Contop factor. This is indicated by small. To express the extent of association or dissociation of solutes in solution. Now, how to express? It is the ratio of normal is correct, and observed, that is the wrong one that you got. Observed means what? Or and observed means or or abnormal molar mass. Okay, that is I is equal to what? Normal molar mass, that is which is theoretically calculated or correct one, and abnormal molar mass means which is experimentally determined. So this is I. Or observed or theoretically calculated. Okay, so this is I. As molar masses are inversely proportional. Just a minute, let me put some ink. বোর্ডটাই খারাপ হলো না কি হলো? Excuse me, let me put some ink. colligative properties. Therefore, Pontoff factor I can also be written as I equal to, see, this we get it by normal molecular mass. We can get it by what? The actual colligative property. Is it not? Hmm? An abnormal molecular mass, we get it by the observed colligative property. So this value will go here and this value will come here. So what I can write? This will go. I'll write down here. Normal colligative property. Oh, sorry. Normal value of colligative property. That is, if the molecule would have been ideal, it would not have been gone for association or dissociation, then this is the one I should get. And what is this? Observed value of colligative So I can write I in the form of molecular mass, I in the form of the colligative property. I can write any one. Possible values of Bonhoeffer factor I. See, I can be more than one. If I is more than one, there is number of the particle has increased. When it will happen? Huh? That is, it indicates dissociation of solute molecules takes place in the solution. So the number of particles increases. Consequently, molar mass. Okay, now the value. The value of I. You need not get so scared. See here. Sodium chloride dissociates to give you Na plus Cl minus. So here you will find value of I is equal to 2. See. Barium chloride Ba2 plus 2 Cl minus. How many? 1 plus 2. So I is equal to 3. FeCl3. Fe3 plus 3Cl minus. I is equal to 4. Okay, I'll give one more. Don't get scared. K4 FeCN6. This is called potassium ferrocyanide. So you get here 4K plus and FeCN6 minus. So 4 plus 1. Okay. So this is I is equal to 5. This is given for entrance. We go. B. I is less than 1. What happens when it will be like this? Association of solute molecules takes place, and as a result the number of solute particles decreases, resulting higher molecular masses. Okay, I'll give you an example. See here. You have taken acetic acid. What has happened here? Hydrogen bonding. Okay, here value of I is equal to half. Similarly, if you have, I'm not doing other example because it's not given in a book. In case of other, it will be Okay, I'll write one more. See, I have taken here. This is called formaldehyde. See, 3 molecules has formed 1 molecule. 1 association. Here value of I is equal to 1. Okay. So now, so I is when I is less than 1, it undergoes dissociation. When I is more than 1, I undergo dissociation. Then what is the third choice? The third choice is I is equal to 1. It is in this case. Solute molecules do not undergo either association or dissociation. Hence, these molecules show correct colligative properties as well as molecular masses. See, example क्या क्या है? Sugar C12H22O11. Glucose C6H12O6. Urea NH2 CO NH2. Naphthalene. Okay, what is naphthalene? C10H8. So you'll get correct. So we have to do some modification in the actual colligative property equations. Okay. So that same equation can be used for both normal molecule and abnormal molecule. Modified equations for colligative negative lowering in vapor pressure. See here, don't write first thing. It is delta P by PA0 chi. This is our original property. Chi B. Or what you write? Delta P by PA0 equal to WB. I told you to remember like that. Omen versus Omen. A. B. See? Now it will modify. So here I will put I. Here I will put. So this is the modified. Then elevation in boiling point. So what was our equation? Delta TB KB into WB into 1000 divided by MB into WA. Here I put A. C. Depression in freezing point. Our original equation was delta TF KF WB into 1000 divided by MB into WA. Okay, what we'll do now? We'll put I. Okay. Now in the osmotic pressure. So we know pi is equal to C R T. I'll put here. We also know that pi is equal to what? N by V R T. So here you can also, and also you know pi is equal to what? W B M B R T by V. So you can put this. So anyone, it depends upon what numerical you are going to do. So this is the part. And Noreen. Hello. Noreen Haidar is there.
Sir.
Noreen. Hello. Can you hear me?
Yes, sir.
Then why you are keeping so quiet? In your school, how many chapters are done?
Yes, sir. In
Yes.
the in in the formula, this like KB and WB, you know, sir. The
Hmm.
small b and big B. What is the difference between the small b
Oh,
and big B?
no, this is the constant here. This is molar
W-
elevation constant, and here WB. See, in our entire book, they have considered A as the solvent and B is the solute. So WB means mass of solute. B is not a multiple, and this B, small b stands for boiling.
And big B, sir.
Big boy is for solvent. Solvent. See, this is
Thank
for
you, sir.
sorry, this is for solute, and B is for solute, and A is for solvent. Clear?
Yes, sir.
Okay, then for